Why did the human story begin in Africa? Why was it this specific landmass and not Europe, Asia, or the Americas? Visualize the Earth as a colossal testing ground. Every continent acts as a separate workstation conducting its own biological trial. Some environments are tropical and steamy, while others are arid and freezing. Some are volatile and unforgiving, others peaceful and lush. Every variable in every ecosystem serves as a distinct component in the recipe of existence. It just so happens that the African experiment is the one that forged the human family tree. This has perplexed anthropologists for decades, but asking why digs deeper. It's a far more intricate puzzle to solve. In this video, I'll lay out the proof. We will look at the fossils, the stone artifacts, and the genetic data that all converge on Africa. However, we will also delve further back into our primate heritage and the planetary changes that paved the way for our species. To truly grasp our origins, we have to travel back to the deep past. A good starting point is the dawn of primate evolution. When you picture a primate, images of chimpanzees, orangutans, or lemurs likely come to mind. Yet, the primate order today encompasses roughly 500 distinct species. We are just one among them. The variety is staggering, but we share a core set of characteristics. We possess prehensile hands, flat nails rather than claws, forward-facing eyes offering depth perception, generalized teeth for varied diets, and comparatively large brains. Scientists have a general time frame for when these features began coalescing into an animal recognizable as a primate. It likely occurred during the transition from the Paleocene to the Eocene, somewhere between 75 and 55 million years ago. It's a broad estimate because the fossil record rarely provides precise timestamps. If you know your paleontology, you understand the significance of this era. It signals the demise of the non-avian dinosaurs. Following their extinction, likely caused by an asteroid, mammals began to rise up and fill the void. The primate timeline extends so far back that our oldest ancestors might have existed alongside the final dinosaurs. Take Purgatorius, for instance. Found in Montana and dating back 66 million years, this tiny arboreal mammal resembled a shrew until you look at its ankles. That's when you realize it's a proto-primate. Those highly flexible joints are a dead giveaway, representing the mobility later primates would use to grip branches. Existing alongside them were the plesiadapiforms. Imagine a creature halfway between a squirrel and a small monkey. Their fossils appear worldwide. Like Purgatorius, they seem to be a bridge between rodent-like ancestors and true primates. The deciding factor linking them to us is their dental structure, which mirrors that of modern lemurs. However, lacking stereoscopic vision, grasping hands, or large brains, they hadn't quite earned full membership in the primate club. The full-time members arrived around 55 million years ago. Known as euprimates, these included groups like adapids and homomioids. They displayed the complete primate package: forward eyes for 3D vision, nails instead of claws on grasping hands and feet, mobile shoulders, and larger brains than their predecessors. But why did these features develop? Experts offer several theories. Initially, it was thought to be a simple adaptation to arboreal life. Critics, however, point out that many tree-dwelling animals never became primates. Another theory, the visual predation hypothesis, suggests primates evolved as stealthy hunters of insects, using keen sight and quick hands to grab prey. Then there is the angiosperm radiation hypothesis. The rise of flowering plants provided new food sources like fruits and nectar, which would have selected for color vision and dexterity. Imagine these ancestors trying to distinguish a ripe red fruit against green foliage. They needed the visual hardware to do it. There is evidence for all three scenarios. They lived in trees, their teeth suggest insect eating, and the timeline matches the spread of fruit plants. Likely, it wasn't just one factor, but a perfect storm of all three. These pressures pushed primate biology in a unified direction. The key takeaway is that primates developed traits that unlocked new ecological opportunities, setting the foundation for a clever, versatile species. Us. The next pivotal chapter in primate history surprisingly didn't unfold in Africa. By 40 million years ago, higher primates, or anthropoids, ancestors to monkeys, apes, and humans, appear in the fossil record. The oldest, a tiny creature named Eosimius, or dawn monkey, was discovered in China. Its heel structure indicates it moved through trees much like modern monkeys do. Discoveries in Myanmar and Pakistan reinforce the idea that Asia was the launchpad for this group. Eventually, they reached Africa. Without knowledge of geology, one might assume they just swung through a continuous forest to get there. But reality is more complex. The Tethys Seaway, a massive ocean connecting the Atlantic and Indian Oceans, once separated Africa and Asia, creating a formidable barrier. Shortly after the 40 million year mark, tectonic movements began reshaping the globe, driven by heat from the Earth's core, creating mantle plumes and convection currents. The African and Arabian plates drifted northward. They eventually collided with Eurasia, creating mountain ranges in Turkey and Iran and fusing Arabia to Africa. Crucially, this activity birthed new landmasses. Volcanic islands rose from the sea, eventually forming the Gomphotherium Landbridge by 20 million years ago, sealing the Tethys Seaway. This disrupted global ocean currents and weather patterns, altering rainfall and creating diverse ecosystems ranging from jungles to savannas. This land bridge was the lifeline our ancestors needed. They likely island hopped to Africa just in time, as a severe cooling event is thought to have wiped out their Asian counterparts. Once safely in Africa, these anthropoids flourished and diversified. This period marks the split between New World and Old World monkeys. While their differences today are subtle, their geography is the real story. The ancestors of New World monkeys somehow crossed the Atlantic to South America, likely on large rafts of vegetation, a theory that sounds wild but remains our best guess. Back in Africa, the remaining lineages evolved into Old World monkeys and apes. The land bridge opened the floodgates for migration around 20 million years ago. Asian mammals flooded into Africa, while African species, including huge elephant-like creatures and primates, moved into Asia. This geologic shift turned a barrier into a highway, sparking a new evolutionary era. By the Miocene, 23 million years ago, the biological experiment ramped up. Apes appeared. Distinguished from monkeys by their lack of tails, larger brains, and complex social structures, apes represent a major step toward humanity. Proconsul, living in East Africa 20 million years ago, is a prime example. With a mix of monkey-like body and ape-like teeth, it represents a transitional form building on millions of years of adaptation. Climate played a huge role here. Around 17 million years ago, a warm period allowed subtropical forests to blanket Eurasia and Africa. Apes used this green corridor to expand outward. The fossil record explodes with diversity. Swamp apes in Spain, island dwellers in Italy, and ancestors of orangutans in Asia. However, this Planet of the Apes scenario collapsed a few million years later as the planet cooled. The forests of Europe dried up, driving species like Australopithecus to extinction despite their advanced chimp-like anatomy and slow growth rates. By the end of the Miocene, the only safe havens for primates were Africa and Southeast Asia. the African survivors would eventually produce chimps, gorillas, and humans. Around 7 million years ago, the human line began to distinctively separate from the ancestors of chimpanzees. The fossil record here is sparse and frustrating, but the evidence points squarely to Africa as our cradle. Evolution here looks less like a graceful progression and more like a messy experiment. While chimps stayed in the trees, our ancestors committed to the ground. We became bipedal. This upright walking is our defining trait. Sahelanthropus chadensis, found in Chad, offers the first clue. While chimp-like, the placement of its spinal cord opening suggests a vertical posture. A million years later, Aurorin in Kenya shows a femur clearly adapted for bearing weight upright. Then came Ardipithecus, or Ardi, about 4.5 million years ago. Ardi was a hybrid of sorts, capable of walking on two legs but retaining a grasping big toe for climbing. The Australopithecus genus followed. This group, including the famous Lucy, showed clear adaptations for walking, such as modified hips and spines. The Latoli footprints in Tanzania freeze a moment in time where these ancestors walked with a heel-toe stride remarkably similar to ours. Why did we stand up? Ironically, a body built for vertical climbing is pre-adapted for bipedalism more so than a quadrupedal body. But evolution requires pressure. The most accepted theory is a convergence of factors. As Africa's environment shifted from dense jungle to patchy woodland, food sources became spaced out. Walking on two legs is more energy efficient for traveling long distances between these patches. It also frees up hands, supporting the postural feeding theory and the provisioning theory. This unique African environment provided the perfect conditions for these traits to stick. In contrast, orangutans in Southeast Asia remained in stable rainforests. Without the pressure to adapt to open ground, they remained arboreal specialists. Our specific genus, Homo, debuted in Africa shortly after 3 million years ago with Homo habilis, accompanied by simple stone tools. Following them was Homo erectus. Homo erectus is pivotal. They looked undeniably human, were fully bipedal, had large brains, and were the first to leave Africa. Their advanced toolkits likely aided this migration. By 1.8 million years ago, they had reached Georgia and Indonesia. This widespread dispersal complicates the narrative. Did regional populations evolve independently? Some scientists distinguish between African Homo ergaster and Asian Homo erectus, while others see them as one variable species. Regardless, the oldest fossils of this type are still African, suggesting an African origin before the Exodus. Now, we arrive at us, Homo sapiens. The oldest fossils found so far are from Jebel Irhout, Morocco, dating back 300,000 years. Another point for Team Africa. However, we weren't alone. Neanderthals, Denisovans, and others inhabited Eurasia. Two main theories explain our dominance. Out of Africa, burst down multiregionalism. Genetics has largely settled this. Africa holds the highest genetic diversity of any continent. Since diversity accumulates over time, this confirms humans have lived there the longest. Non-Africans possess only a subset of this diversity, indicative of a smaller breakaway group migrating out later. While we did interbreed with Neanderthals, our primary genetic root is African. Recent studies suggest a Pan-African social network. For hundreds of thousands of years, early humans in Africa traded materials like obsidian, pigments, and ostrich beads over vast distances. This exchange of genes and ideas prevented isolated stagnation. Much like how rock and roll was born from the mixing of blues, country, and gospel, modern human behavior emerged from the recombination of different African populations. This mosaic evolution gave us the adaptability to survive any environment, eventually allowing us to outcompete other hominins globally. Science demands skepticism. Are there arguments against the African origin? There is Danuvius, an 11-million-year-old ape from Germany capable of walking upright in trees. Then there is the theory of Asian origins for sapiens. Could Homo erectus in Asia have evolved into Homo sapiens and then migrated back to Africa? It's a possibility, though genetic evidence links us closer to African chimps than Asian apes. Finally, there are old fossils found outside Africa. Finds in Israel and Greece show humans left Africa earlier than we thought. However, these likely represent failed or temporary migrations rather than the main source of modern humanity. But the story doesn't end with us simply leaving Africa. To truly understand our dominance, we have to look at what fueled it. It wasn't just our bones, it was the climate engine of the continent itself. Consider the Sahara Pump theory. For the last few million years, the Sahara has not always been a desert. It cycles between a dry, arid wasteland and a lush, green oasis filled with lakes and rivers. This cycle, driven by wobbles in Earth's orbit, acted like a massive biological pump. During green periods, humans could expand across North Africa, meeting, mating, and sharing ideas. When the desert returned, it forced these populations to retreat or pushed them out of the continent entirely. This environmental instability was a crucible. It forced our ancestors to become the ultimate generalists, capable of surviving anywhere. This adaptability led to what scientists call behavioral modernity. Roughly 70,000 to 50,000 years ago, something clicked. We moved beyond simple survival. We see the explosion of complex symbolic behavior. In places like Blombos Cave in South Africa, we find ochre processing kits and engraved geometric patterns dating back 75,000 years. This implies a capacity for abstract thought, the ability to imagine things that don't exist in the physical world. This cognitive leap allowed for the creation of myths, religions, and complex trade networks that bound thousands of unrelated individuals together. As these cognitively equipped humans poured out of Africa, they encountered their long-lost cousins, the Neanderthals in Europe and the Denisovans in Asia. The question of what happened next is one of history's darkest mysteries. Did we wipe them out in a prehistoric genocide, or did we simply out-eat and outbreed them? The truth is likely a mix of competition and assimilation. We know we interbred. Most non-Africans today carry 1 to 2% Neanderthal DNA. This ancient tryst gave us genetic gifts, like improved immune systems to fight Eurasian diseases and adaptations for different skin tones. But as Homo sapiens populations swelled, fueled by our superior social organization and projectile weapons, the Neanderthals retreated. They were pushed into marginal environments, mountaintops, and dense forests until, about 40,000 years ago, their fires went out forever. We became the last human species standing. This victory marked the end of purely biological evolution as the primary driver of our story. We entered the era of cultural evolution. We stopped waiting for our bodies to change to fit the environment and started changing the environment to fit us. We sewed tight-fitting clothing to survive the Arctic. We built boats to cross to Australia and the Americas. And eventually, roughly 12,000 years ago, we made the most radical shift of all: agriculture. By domesticating plants and animals, we locked ourselves into a sedentary lifestyle, leading to the rise of cities, states, and the modern world. All of this complexity, all of this history, is the direct result of that long, messy experiment that began in the trees of Africa. The weight of evidence, fossils, tools, DNA, and the climatic history of the continent overwhelmingly favors Africa. The continent's shifting landscapes forced early primates to adapt. Its tectonic history allowed for crucial migrations, and its diverse environments forged the most adaptable species Earth has ever seen. But I want to hear from you. Do you find the evidence for the out of Africa theory conclusive, or does the Eurasian angle intrigue you? And a fun thought experiment. What would civilization look like today if we had evolved from the New World monkeys of South America instead? Drop your thoughts in the comments. If you enjoy deep dives into prehistory, consider subscribing to the newsletter in the description for more updates and recommendations. Thanks for watching.